Hello friends, from today we will start our new subject, that is data structures and algorithm. So here this is the first class, Introduction to Data Structure. The first topic is data structure taxonomies. So in this class we will see the data structure definition, categories of data structures, and the characteristics of data structure. First, let us see what is data structure. Data structure is a method of organizing and storing data in a computer. Okay, so that the data can be organized, processed, stored, and retrieved quickly and effectively. Okay, so we have to store the data in the computer. So this is computer memory. In this computer memory, we need to store our data, right? So what is data? Data is nothing but the information that must be processed and stored in the computer, right? So what type of data we know? The data may be the numbers, characters, dates, photos, audios, videos, and etc. So these are all data. So these data should be stored on the computer. That should be follow some structure. If the structure is perfect, then the operation that should be performed on the data will be very easy and effective, right? And the next one is algorithm. So the algorithm is instruction or rules, that is the sequence of instructions that is used to be organized or processed the data. Okay, that is, it specifies the relationship between various data elements. So in the data structure we have to use the data to be organized, and this data should be same type, right? The structure has an impact on the efficiency of data operations. If the structure is perfect, then the operations will be performed on the data will be very easy, and the result will be effective result or efficient result, right? Next, let us see the categories of data structure. When come to data categories, two important categories are there. First one is linear data structure and second one is non-linear data structure. When come to linear data structure, these four types of very common and important, right? The first one is array, the second one is queue, stack, and linked list. Right. When come to non-linear data structure, trees and graphs are there. And let us say all those things in brief in our forthcoming slides. The first category is linear data structure. Linear data structure means the data elements are arranged sequentially or linear fashion. Right here, the each element is attached to its previous and next adjacent element. That is, the data will be stored in a linear fashion. Okay, one after another. So this is first element, second element, third, fourth, etc. up to nth element. Okay, all the data will be stored in the sequence fashion. Then this is called as linear data structure. Right here, there are four important types of linear data structures are there. First one is array, second one is linked list, queues, and stack. Okay, let us see those things one by one. The first type is array structure. Array is nothing but the collection of similar data types which are stored in contiguous memory location. Okay, so for example, this is array. So in the memory, the data will be stored here. So this is the first data. 2, 1, 5, 3, 4 are stored in the memory location. So the address of 2 is 1005. The address of 1 is 1006. Likewise. So continuously the data will be stored. That is, a sequence of memory location will be reserved for this array. Right? Here the array index starts from 0, ends from n minus 1. Okay, starts from 0 to n minus 1. That is, n number of data will be stored in continuous memory location. Continuous memory location. Okay, the index starts from 0 to n minus 1. So how many data will be stored in an array? N number of data will be stored here. And there are two types of arrays are there. First one is one dimensional array or single dimensional array, and second one is multi dimensional array, 2D, 3D, 4D, etc. Right? Okay. The array is the static data type. Static data type means during the declaration time itself, we need to define the size of array. What is the size of array? Size will be fixed here. Size of array is fixed. That means during runtime, the changing array size is very difficult. And the next thing is, suppose we want to insert one more item in between these things. For example, I need to insert 6 here in between 5 and 6 without deleting the another item. That is, we are going to increase one more item in between is also very difficult during runtime. Okay, and the size is packed. Resizing is very difficult in array. So to overcome these drawbacks, we will go to linked list. The next one is linked list. To overcome the drawbacks of array, we introduce this linked list. Here, the data are stored in sequence of linked nodes. Okay, so the data will be stored in node, and node is having two slots. The first slot is for data and second slot is for address, which represent the next node. Okay, so the node is having two slots. The first slot data will be stored and the second slot address will be stored. The address is used to point the next node, right? That is, the next node address will be stored here. Here the linked list helps memory allocation, that is dynamic memory allocation. Dynamic memory, that is, based on the requirement, the list number will be increased or decreased. The size of the list will be increased or decreased. Okay, here we have three different types of linked list. First one is singly linked list. So this is the singly linked list. So in the singly linked list, this is node. The first node is head node, right? Data will be stored here. This is the address of next node. And when come to last node, okay, here null address is node. Null address is stored here because there is no further node is here, right? So this is singly linked list. When come to doubly linked list, the second type is doubly linked list. Here the node is having three slots. Node is having three slots. So in this three slot, the middle slot data will be stored. Data is stored in the middle, and here this is the address of previous node, and here the address of next node will be stored. Okay, so this is called as doubly linked list. And the last one is circular list. When come to circular list, this is exactly same as singly linked list, that is only two slots are there, but in the last node the address portion is pointed to the first, that is the head node. Hence it will become a circle, right? So this is circular list. So there are three types of linked list. First one is singly linked list, doubly linked list and circular list. The next important structure is queue data structure. This is another linear data structure. Here the elements are stored sequentially. For example, this is the list queue. So why the list is called as queue? The data will be entered at one side and exit in the another side. Hence it is called as queue. For example, this is front and this is rear. So entry will be at the rear side and exit is at the front side. Hence it is called as queue. Okay, that is, the data which entered first will be served first. So this is 1, 2, 3, 4, 5, right? So which comes first? The first data item comes first, then this also served first. Hence it is also called as FIFO approach, that is first in first out approach. That is first in first out list is called as queue list. Okay, this is the queue. The data will be entered in this direction. A is the first item, B second, this is third, fourth, fifth, sixth, right? So which comes first? A is comes first. Hence the service will be provided only for A, not in the B. Hence which will deleted here? A will be deleted first. And once we delete the A, then B will become the first. Right, isn't it? And there are three different types of queues. First one is simple queue, second one is priority queue, and third one is circular queue. Okay, we will see all these queues in our forthcoming classes. Okay, now let us see the queue operation. Okay, so in the queue operation, we have to insert the item into the queue. Where we are going to insert? Insert is at the rear side, right? Where we are going to delete? Where we are going to delete? Delete in the front side. Okay, so the insert operation is nothing but NQ and delete operation is nothing but DQ. Okay, the next structure is stacked data structure. This is another important linear data structure. Unlike queue, here the insertion and operation, that is deletion, will be performed at only one end, that is the top end. Okay, so this is the stack structure. Here we are going to insert the data at the top and remove the data only at the top. Okay, for example, this is like this: the first item, second item, third item. This end is closed. Okay, this is open. Hence the insertion and deletion will be taken place only at the open end, right? So this type of structure is called as last in first out structure. Last in first out structure, that is the data which entered last will be served first, right? So this is called as stack data item, that is entering and retrieving data is possible only at one end. The operations in the stack are push and pop, that is push an item into the structure and pop the data item from the structure, right? Insertion and deletion. And these are some of the example of stack. Examples of stack, that is a stack of coffee trays. Coffee trays will be arranged one by one. This is a stack of coins, and this is stack of box, and this is stack of folded clothes. So if we arrange in this manner, which will be taken out first? The item which is placed in the top, that will be taken out first, that is last in first out. So these are the operations of stack. So push means the data item will be inserted into the stack, that is called as push operation. And pop operation means the data will be taken out from the stack. Okay, which data item will be taken out first? The item which is entered last will be taken out first. Okay, that is last in first out list is stack. And next let us see the nonlinear data structure. When come to nonlinear data structure, two types of structures there. First one is tree and second one is graph. Okay, first let us see the tree structure. Tree is the structure. Here the data are arranged in hierarchical order. Okay, so tree is a collection of nodes and edges. So this is node and this is edge, that is the circles are represented as nodes and the arrows are represented as edges. This is node. Okay, so where the data will be stored? Here the data will be stored in the node. And what is the purpose of edge? Edge is used to connect the nodes. Okay, and it also represent the relationship between the nodes. Right? And in the tree we are having three different types of nodes. Three different types of nodes there. The first one is root node. So this is the top of the tree. The tree structure will starts only from the root node. And the second type of nodes are called as branch nodes. Branch nodes. Okay, so these are all branch node. And the third type of nodes are called as leaf node. Leaf node. Okay, so leaf node, in the leaf node it does not have any branches. Here we have 5 leaf nodes, right? So the node which does not have any branch is called as leaf node, right? So this is the example of tree. Okay, so based on type of tree, we are having different types, right? General tree. So this is example for general tree. Binary tree. Binary tree means a tree which has only 2 branches. For every node we have either 1 or 2 branches, maximum 2 branches. And binary search tree, AVL tree, red black tree, splay tree, T-tree, B-tree, and etc. are different types of trees we have. Okay, and this is the example of tree operation. So this is the example of binary search tree. In the binary search tree, we try to insert the value 7 by using a node. So this is the place of that 7. Okay, so this is insert operation in binary search tree. And here this is another operation, that is searching operation. So we are going to implement this searching operation by using two methods. First one is depth first search and second one is breadth first search. Okay, so we will see all those things in our forthcoming classes. The next important nonlinear data structure is graph structure. Okay, so this is a static type. Static means the size is fixed during the compile time itself. We cannot resize the graph during the runtime. Okay, so here also the graph is a collection of nodes and edges. Node is used to store the data 1, 2, 3, 4, 5, 6. Okay, likewise we can store the values in the nodes and the edges are used to connect the nodes. Okay, so these are all called as edges and this is node. Okay, and the edges are used to give the relationship between nodes also. Okay, it represents the relationship between the nodes, data elements. Okay, and the graph provides a very powerful framework for solving more real-time problems. Okay, from various domains like network analysis, social media analysis, and route planning, right? So graph is a very powerful data structure. The very big difference from tree and graph are, tree is the dynamic structure, okay, and the edges will be always towards the leaf node and there should not be any loop in the tree. This is the tree structure, right? But tree is a dynamic type. Dynamic type means based on the requirement the tree size may be increased during runtime. During runtime the nodes may be increased or decreased, right? So this is tree. But in contrast to tree, this is the graph. Graph is a static one. Static one. Here loop is uh, allowed here. Okay, here the edges are both directed edges or non-directed edges. Directed and undirected. Both undirected and directed are allowed here. Okay, and here this is the node. Node, the data will be stored, and edges sometimes it may have weight. The edges may have weight. So these are all weight here. Okay, so this graph operation is used to find the shortest path from the start node to the goal node. Okay, so in this way we can find the shortest path. Okay, and all the other graph operations we will see in our forthcoming classes. And next let us see the basic operations for all the data structure. So these are four basic operations. First one is traversal, insertion, deletion and search. Okay, traversal. What is meant by traversal? This operation used to print all the elements in the array or all the elements in the tree or graph, whatever it may be. Either it is linear or non-linear. It will visit all the data items. Right? So this is called as traversal. And second one is insertion, that is used to insert a particular item in the data structure. New data will be inserted into the structure is called as insertion, whatever it may be. Either it is linear structure or non-linear structure. Okay, deletion means that is used to delete an existing element from the particular index of the structure. Right, so removing an existing item is called as delete operation. And the last one is search operation. Search means it is used to search a particular element by using given index or by using the value. For example, the fifth position data will be removed, or for example the data value 100 will be removed from the array or from the uh, tree or graph. Okay, so by using the position or by using the value, we search a particular item in the list is called as search operation. So which are the basic operations we have? Traversal, insert, delete and search. Now let us see why we need to study the data structure, that is the importance of data structure. Data structure is the basic concept in computer science which is used to manage and analyze the data. How we are going to manage, analyze and operate the data for a particular problem. For those things the data structure is very important. Okay, first the data structure in problem solving. Okay, so it is very much helpful to understand the nature of problem at deeper level. Okay, if you want to understand the nature of problem, data structure is very important. Once we understand the problem, then we can solve many real world complex problems. Right? If the data size is small, then no problem. If the size is increased, then we have to learn the data structure. That is how the data will be arranged, how the data will be searched, insert, delete, traverse. For all those things, we need to learn the data structure. Okay, and second one is algorithm design. That is how the data structure is important for designing algorithm. Okay, it is very much helpful for developing effective algorithm for performing operations on the data. Okay, which are the basic operations? Searching, insertion, deletion, etc. Okay, if the data size is very huge, then we need to design effective algorithm for performing operations on the data. For that, the data structure is very important. And now let us see the characteristics of data structure. So we already know that the data structure is the systematic way which is used to organize the data. Okay, the data may be stored in the data structure, that may be a table structure or in a data store. In what way or in which system we are going to arrange those data in the data store, which is called as data structure. See, for that some of the characteristics are very important. Linear or non-linear. So based on the requirement, the data should be arranged either in linear order or in non-linear order. That is hierarchical order. Right? And second one is static and dynamic. Static, that should support static and dynamic. That means during runtime the structure may be increased or shrinked out. So this is dynamic. That should support both static and dynamic structure. And the third important one is improved time complexity. That means within the less time, the problem should be solved. That is, the time complexity should be less. And the next one is, fourth one is better space complexity. Space complexity means within the limited runtime space, the problem should be solved. So the space should be less. That should occupy very less space during runtime to solve the problem. And the fifth one is efficient data retrieval. That is, a single data or set of data should be retrieved from the structure. And the sixth one is better data management. That is, insert, delete, modify the data in the data structure should be very effective and efficient, right? And the seventh one is solving complex problems. So it should support, that is, it effectively solve the complex problem with less amount of time and space. And the next one is adaptability. So it should adapt any type of data and it should support all type of operations on the data. That is called as adaptability. And the next one is flexibility. Flexible, it means the ability to dynamically grow or shrink the size of data, or the ability to efficiently operate the elements. That is, the data and operations on the data should be very flexible. That should be very flexible. So these are important characteristics of the data structure. In this class, we learned the definition of data structure, categories of data structure. Here, there are two basic categories. First one is linear data structure and non-linear data structure. When come to linear data structure, we learned arrays, queues, tags, and linked list. In non-linear, we have seen trees and graph, right? After that, we learned the basic operations, that is four basic operations, and why data structure is important. After that, we have seen the characteristics of data structure. And in the next class, we will see another important topic from first unit. Thank you.